All right, in this video, we're going to talk about the review sheet for the final exam. And what's on this review sheet is going to be similar to the problems that you'll see on your actual final exam. So we're going to start with problem number 1, which is h of 5. Here we're going to use the graph that's on the right-hand side to find the following values if they exist. So with h of 5, we go to 5 on the x-axis. And notice here that we do have a point at 5. And the y value, or the h of x value that corresponds to that point at x equals 5 would be 8. So that means h of 5 would be 8. All right, and then part B that asks for the limit as x approaches 5. Of h of x. So in this case here, here's 5. As we let x approach 5 from the left side, you'll see that it's getting closer and closer to this y value of 6. And as x approaches 5 from the right side of 5, you can see that the graph gets closer and closer to this y value of 6 as well. It'll never reach 6, but it gets closer and closer to 6 on both sides, the left side and the right side. So that means the limit as x approaches 5 of h of x will have to be 6. Keep in mind that the limit for just this, you have to have the left side of it approaching to one number, and the right side, it must be approaching the same number. Both sides have to approach that same y value, or h of x value, I should say. All right, now part C is h of 7. So we're trying to find the value of h of x when x is equal to 7. Here's 7. Notice that 7, there is an empty circle at 7. So that means here, the value of that function when x is equal to 7 does not exist. Does not exist. And now part D. Part D is the limit as x approaches 7 of h of x. Now we've already established that at 7, the value does not exist due to that empty circle. But if we take the limit from the left and to the right, you're going to see on the left side of 7, it's getting closer and closer to a y value of 3. And on the right side of 7, it gets closer and closer to a y value of 3 as well. So the limit as x approaches 7 of h of x is 3. And then for part E, we got the limit as x approaches 8 of h of x. And in this case here, at 8, well, it is at a y value of, in this case, 4. So at x equals 8, that y value there will be 4. Okay, and if you were to go to the left of 8 and to the right of 8, both sides would get closer and closer to 4. So the limit as x approaches 8 of h of x will be 4. Okay, so that's how we do problem number 1, doing those limits. In number 2, A, B, and C, we're going to evaluate the following limits. Here we got the limit as x approaches negative 2 of 7x plus 1. So let's start with that. So it's part A, the limit as x approaches negative 2 of 7x plus 1. Well, this is just a polynomial function, so that means we can apply the direct substitution to this. So that means here, we just replace that x with the negative 2. So it'll be 7 times negative 2 plus 1. And 7 times negative 2 is negative 14. Negative 14 plus 1 would be negative 13. So the limit as x approaches negative 2 of 7x plus 1 will be negative 13. In part B, we have the limit as x approaches 4 of x squared minus 2x minus 8. All that's divided by x minus 4. And I want to find its limit. Well, the problem is if I do direct substitution, I'm going to end up with a 0 in the denominator. So what I'm going to try to do here is factor wherever possible and divide out those common factors. That way I will be able to take the limit as x approaches 4. So I'm going to bring over the limit as x approaches 4. If I factor out x squared minus 2x minus 8 into two binomials, that x squared breaks up as x, and factors of negative 8 that would give me negative 2x as a middle term would have to be a minus 4 and a plus 2. Now, as you can see, I can divide out x minus 4. And that will leave me with the limit as x approaches 4 of x plus 2. Excuse me. Now, I can do direct substitution by replacing the x with the 4, so it'll be 4 plus 2 equaling to 6. So the limit as x approaches 2 of x squared minus 2x minus 8 divided by x minus 4 would end up being 6. Now, part C, I have this. The limit as x approaches 441 of the square root of x minus 21 divided by x minus 441. And he'll want to find this limit as well. Well, if I did direct substitution, I would still get a 0 in the denominator like in part B. So that means here I need to take this square root of x minus 21 and multiply it by what they call the conjugate. What that means here is this. I have the same terms, but the sign in between it would be opposite. So in this case, let me write over the limit as x approaches 441 of, this is the square root of x minus 21 divided by x minus 441. So I'm going to multiply the numerator and the denominator by what they call the conjugate. So I have the square root of x plus 21. That would be the conjugate. Same terms, but the sign changes to the opposite. It's a minus, so it changes to a plus. And I multiply the denominator by the square root of x plus 21. Now, I still have the limit as x approaches 441. I have to bring that down because I haven't taken the limit yet. Notice in the numerator, I have the sum and the difference of the same two terms. To multiply that out, I square the first term. I square the square root of x. That would give me x, because squaring and taking the square root eliminates the radical. So the x minus the square of the second term. 21 times 21 would be 441 over, and I'm going to leave the denominator as x minus 441 times the square root of x plus 21. Now notice I will be able to divide out that x minus 441. That would mean I will have the limit as x approaches 441 of 1 divided by the square root of x plus 21. Now I can do direct substitution by replacing the x with 441. Excuse me again. So it'd be 1 square root of over the square root of 441 plus 21. And the square root of 441 is 21, so 21 plus 21 in the denominator would be 42. So and I'll have 1 over 42 as the final answer. So the limit as x approaches 441 of the square root of x minus 21 divided by x minus 441 will end up being 1 over 42. All right, now problem number 3, A and B, is to determine the limits of each of the following and use D and E if the limit does not exist. So, in part A, we have the limit that's a limit as x approaches infinity of 9x cubed minus 2x squared plus 3x, all divided by negative x cubed minus 2x plus 7. So in this case here, what I would do here is divide each term in the numerator and the denominator by the variable with the highest exponent. And in this case, my highest exponent is 3, so I'll divide every single term by x cubed. So here's what I have. The limit as x approaches infinity of 9x cubed will be divided by x cubed minus, and then 2x squared will be divided by x cubed, and then plus 3x will be divided by x cubed, divided by, and then negative x cubed will be divided by x cubed, minus 2x divided by x cubed, plus 7 divided by x cubed. And then if I simplify all of this, I'm going to bring down the limit as x approaches infinity still. 9x cubed divided by x cubed would just be 9 minus 2x squared divided by x cubed, that would be a 2 over x, because one of the x's will be in the denominator. Then plus 3x divided by x cubed, that would be 3 over x squared. All that's divided by negative x cubed divided by x cubed would be negative 1 minus 2x divided by x cubed. I'll have a 2 in the numerator, but 2 of the x's will be in the denominator, so it'll be 2 over x squared plus bring over the 7 over x cubed. Now there is a rule that says this. As you take the limit as x approaches infinity of 1 over x to whatever that exponent is, that's going to end up going to 0. So in this problem, as we let x approach infinity, this 2 over x goes to 0. 3 over x squared would go to 0. 2 over x squared would go to 0. And 7 over x cubed will also go to 0. So I'm going to end up with this. The limit of a constant is a constant. So the limit as x approaches approaches infinity of 9 will be 9 over the limit as x approaches infinity of negative 1, that's negative 1. So 9 divided by negative 1 ends up being negative 9. So that would be the limit as x approaches infinity of 9x cubed minus 2x squared plus 3x divided by negative x cubed minus 2x plus 7 ends up being negative 9. Okay, now problem number 4 is this. Evaluate the limit as x approaches infinity and of f of x and the limit as x approaches negative infinity of f of x where the function f of x is equal to, I forgot to do part B. Part B is this. The limit as x approaches negative infinity of 5x to the 7 minus 6x to the 6 plus 1. I'll go ahead and do that down here. apologize for that. I was just getting a little bit too ahead of myself here. So here we have the limit as x approaches, and this time negative infinity, of 5x squared, 5x to the 7th minus 6x to the 6th plus 1. I'll look at the leading term to find out what that limit is going to be. So it's the limit as x approaches negative infinity of just a leading term, 5x to the 7th. In this case here, we're going to negative infinity, so this variable to an odd power would end up being negative. And it's just not going to a finite number, so it's getting smaller and smaller and smaller, so it's got to be negative infinity. For the limit as x approaches negative infinity of 5x to the 7th minus 6x to the 6th plus 1, negative infinity. Okay? All right, now part number 4 is this. We got the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x that we want to evaluate for this function. F of x is equal to 6x squared minus 8x plus 7 over 2x squared plus 1. Then give the horizontal asymptote of f, if any. So here we got f of x is equal to 6x squared minus 8x plus 7 divided by 2x squared plus 1. And I'm going to start with the limit as x approaches infinity. And my f of x is that 6x squared minus 8x plus 7 all divided by 2x squared plus 1. Well, in this case here, I'm going to divide every single term in the numerator by and the denominator by the highest exponent in the denominator, which is your 2, x squared. So that 6x squared would be divided by x squared minus 8x would be divided by x squared plus 7 divided by x squared. All that's divided by, and in the denominator 2x squared will be divided by x squared plus 1 will be divided by x squared. And of course, if we simplify this, we have the limit as x approaches infinity of 6x squared divided by x squared, that's 6, minus 8x divided by x squared will be 8 over x, plus 7 over x squared. All that's divided by 2x squared divided by x squared is 2 plus 1 over x squared. And I'm going to use that rule that says if you take the limit as x approaches infinity of 1 over x to whatever your power is, that's going to go to 0. So as we let x approach infinity, this 8 over x will be going to 0, 7 over x squared goes to 0, and 1 over x squared goes to 0. So that means I'm going to be left with the limits of constants will be a constant, so the limit as x approaches infinity of 6 will be 6 over the limit as x approaches infinity of 2, which is be 2. 6 over 2 ends up being 3. So the limit as x approaches infinity of that function that's given to us is 3. Okay? Now, if I take the limit as x approaches negative infinity, the limit as x approaches negative infinity of f of x, now if I go through that whole thing that I just did for positive infinity, I'm going to get the same thing. I'm going to end up getting the same thing. So that means that the limit as x approaches negative infinity of that function will also be 3. Okay? Because notice we have x squared and x squared here. Same thing. So my horizontal asymptote, both the limits as x approaches infinity and negative infinity has to be the same value for you to have a horizontal asymptote. And in this case, the horizontal asymptote would be the line y equal 3. Okay. All right, now problem number 5 is where we're going to be using the intermediate value theorem to show that the equation x cubed plus x plus 3 equals 0 has a solution on the interval negative 2 to 1. That means it has a 0 on that interval. Then you're going to use your graphing calculator to find all the solutions to the equation on the given interval. So in problem number 5, we have this. We have x cubed plus x plus 3 is equal to 0, and the interval is from negative 2 to 1. Well, let's look at this part right here. The one on the left-hand side, x cubed plus x plus 3, that's your f of x. We want to know if it's continuous on all in this interval and for all x. Well, it's a polynomial function, so that tells me it's continuous everywhere. So f of x is continuous. Because any x value that you assign to it, you will always get a value for f of x. So for all x, your function f of x is continuous. Now we need to verify that there is a 0 between negative 2 and 1. Well, since f of x is equal to x cubed plus x plus 3, let's replace the x with negative 2 and the x with 1. Well, for f of negative 2, this would be negative 2 cubed plus negative 2 plus 3. Well, negative 2 and you cube it is negative 8. And I'm going to write plus negative 2 as minus 2 plus 3. So negative 8 minus 2 is negative 10. Negative 10 plus 3 is negative 7. So at negative 2, f of negative 2 would be negative 7. Now for f of 1, my other endpoint. This will be 1 cubed plus 1 plus 3. Well, 1 cubed will be 1 plus 1 plus 3. 1 plus 1 plus 3 will give you 5. Notice that there's a change in sign. At negative 2, I came up with a negative value, but at positive 1, I came up with a positive value. So that tells me that there is a 0 between the interval of negative 2 to 1. So I know that my f of x would be equal to 0 at x equal to what value? Well, let's use our graphing calculator. Let's go to y equal to, clear this equation out. Now, the one on the left side, I will put into y1 that x cubed plus x plus 3. So it'll be x hat key and then cube, and then get out of the exponential plus x plus 3. Then I'm going to go down to y2 and put in what's on the right side, the 0. And you know what I'm going to do here? I'm going to move this cursor over to the left-hand side all the way to the left. And I'm going to press enter because I want that line to be bold. Okay? Now I'm going to do zoom 6 for the standard window. Here you see the graph of f of x equal to x cubed plus x plus 3. And this bold line you see here is y equals 0. That's your x-axis. Now we want to find out where do the point where these two intersect. And if you want to try to see this a little bit better, try to press zoom, and then number 2, and then from 0 to 0. Okay. But you want to just focus on this right here, the point of intersection. So to do that, I'm going to press second and trace for the calculate menu. I'm going to select menu item number 5 for intersect. And then for the first curve, I'm going to put the cursor as close as I can to that point of intersection. And then I'm going to press enter 3 times. 1, 2, and 3. And that will tell you your 0 for that function. And to 2 decimal places, this will be negative 1.21. So my f of x value will be, my f of x function will be 0 when x is equal to negative 1.21. Okay, so that's how we do problem number 5. All right, number 6 is this. Here we're going to find the derivative of each of the following functions here. That's using those rules that we talked about in chapter 3 for derivatives. So I'm going to move this up. (6a) is this. F of x is equal to 8x to the 6 minus 22x plus e to the third. And here I want to get its derivative. So that means f prime of x would just be this. Using the power rule on the first and the second terms, I can bring the 6 down and multiply it by 8. That would be 48. Copy the x over to the 1 less power. 6 minus 1 would be 5. And then minus the derivative of 22x, that's simply going to be 22, plus e cubed. That's a constant. Actually, that is a constant. So the derivative of a constant is 0. So I can just simplify this as 48x to the 5th minus 22. And that's all there is to it. All right, now part B, g of t is equaling to 12 times the square root of t. And we just want to find the derivative of that. Well, g prime of t is this. I'm going to bring the 12 down. Now, I did talk about this in class where if you take the derivative with respect to x of the square root of x, that's going to be 1 over 2 square root of x. And since I have the t, the derivative of the square root of t would just be 1 over 2 times the square root of t. Okay. I mean, you can change that to t to the 1/2 power and then use the power rule for that. Okay. Now if I divide this 2 into the 12, that would go 6 times. So I'll have the 6 in the numerator over the square root of t. All right. So that's what the derivative of, or that's what g prime of t will be, 6 over the square root of t. All right, number 7, A and B, is to use the product and quotient rules to find the derivative of each of the following. Okay, so I'll go ahead and move this sheet of paper over and write the problems of 7A and 7B. So in 7A, we got this. Y is equal to 8x squared minus 6 times 3x squared minus 7x plus 2. In this one, we must use the product rule. to take this derivative. So here's what we're going to do here. If you recall the product rule, which is of course dy dx, that's going to be the first times the derivative of the second plus the second times the derivative of the first. And in this case, this is the first, and that's the second. So here the first is your 8x squared minus 6 times the derivative of this second piece right here. The derivative of 3x squared, that will be 6x, minus the derivative of 7x will be 7. And then plus the second, which is that 3x squared, minus 7x plus 2, times the derivative of the first. The derivative of 8x squared would be 16x. And of course, the derivative of minus 6 will end up being 0. So that's how we use the product rule here. Now let's go ahead and simplify this. The first part, I need to use the FOIL method. So if I multiply 8x squared times 6x, that's going to be 48x to the third. 8x times a minus 7 will be a minus 56x squared. I should say 8x squared times negative 7. That'll give you this. Inner will be minus 6 times 6x will be a minus 36x. And then minus 6 times the minus 7 will be plus 42. Now for this, I have to distribute the 16x over the 3x squared minus 7x plus 2. 16x times the 3x squared will be 48x cubed. 16x times a minus 7x will be a minus 112x squared. And then 16x times a 2 will be plus 32x. Now let's combine like terms here. 48x cubed and 48x cubed added together will be 96x cubed. Minus 56x squared and a minus 112x squared will be a minus 168x squared. 36x minus 36x and a plus 32x will be a minus 4x. And then only thing left is the plus 42. So the derivative using the product rule will give you 96x squared minus 168, I should say 96x cubed. That's 48x cubed and 48x cubed, that's 96x cubed. My mistake. So it's 96x cubed minus 168x squared minus 44x plus 42. Okay, so that's part A. All right, part B. Here we got f of x, and that's equal to 3x squared minus 9x plus 8. Whole thing is divided by 7x plus 1. Now here we have to use the quotient rule. That's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the square of the bottom. So here f prime of x will be this. The bottom, which is your denominator, that's 7x plus 1, times the derivative of the top. The derivative of 3x squared minus 9x plus 8, that would be 6x minus 9, minus the top, which is going to be that 3x squared minus 9x plus 8, and I'm putting that in parentheses, times the derivative of the bottom. The derivative of 7x plus 1 is 7, divided by the square of the bottom. 7x plus 1, and that's going to be squared. Okay, so now let's simplify the numerator a bit. This part I need to use the FOIL method. So 7x times 6x will be 42x squared. The outer 7x times a minus 9 would be minus 63x. Inner 1 times 6x will be plus 6x. And then 1 times a minus 9 would be minus 9. Now I'm going to do this, distribute the negative and the 7 over that 3x squared minus 9x plus 8. Well, 7 times 3x squared is 21x squared, but the minus sign will make it minus 21x squared. Then 7 times the minus 9x will be minus 63x. The minus sign will make it plus 63x. 7 times 8 is 56. The minus sign will make it minus 56. All that will be divided by the quantity 7x plus 1 squared. And now we're going to go ahead and combine some like terms here. I do see I have a minus 63x and a plus 63x. That's gone. I can get rid of that. Let's see, 42x squared minus 21x squared would just be 21x squared. And then all I have is plus 6x. Negative 9 and a minus 56 would be minus 65. That'll be divided by the quantity 7x plus 1 squared. And I would go no further than that. Okay, so that is the answer to part B of number 7. Okay, number 8, A and B, deals with trigonometric functions. So here we're going to find the derivative of each one of these. And it's important that you do know your derivatives of your trigonometric functions, by the way, that we talked about back in section 3.5, or be familiar with them. All right, number 8. Here we got y is equal to the sine of x plus 8e to the 0.5x. Okay? So that means if I do dy dx, take the derivative of each term. The derivative of the sine of x is the cosine of x plus, bring this 8 down, the derivative of e to the 0.05x, that's simply e to the 0.05x. But I have to multiply it by the derivative of that exponent. The derivative of 0.5x will just simply be 0.5. Now let's simplify this a bit. Well, bring down that cosine of x. I can take 1/2 of 8, that's going to give me 4, so that'll be plus 4 e to the 0.5x. And that's all there is to it. So that derivative would be cosine of x plus 4 e to the 0.5x. All right, now part B of number 8. Part B says this. We have y equal 3 secant of x plus 3 cotangent of x. And we want to find out what the derivative of that equation would be. So in this case here, dy dx. Bring the 3 down. The derivative of the secant of x is this. The secant of x tangent of x. Plus, bring the 3 down. The derivative of the cotangent of x would be simply negative cosecant square of x. Negative cosecant square of x. So if I simplify this, this will be 3 secant of x, tangent of x. This plus sign and that minus would be minus 3 cosecant square of x. This negative will make the plus or minus. So my final answer there would be 3 secant x tangent of x minus 3 cosecant square of x. Okay. All right, problem number 9. Rates of change. Suppose the position of an object moving horizontally after t seconds is given by the function s is equal to f of t equaling to 2t squared minus 3t, where s is measured in feet, with s being greater than 0, corresponding to positions right of the origin. Using the interval from 0 to 4, where t is greater than or equal to 0 and less than or equal to 4, you're going to answer the following. Part A, you're going to find the velocity of the function, and when is the object stationary, moving to the right and moving to the left. Part B is to determine the velocity and acceleration of the object when t is equal to 1, and part C, determine the acceleration of the object when its velocity is 0. Okay, so I'm going to continue, put number 9 on the next page. So here we have s of t, or s equaling to f of t, I should say. S equaling to f of t, and that's equal to 2t squared minus 3t. And my interval is where t is greater than or equal to 0 and less than or equal to 4. Part A, they want the velocity function. And that's v of t, which means I have to take the first derivative of that function. So the derivative of 2t squared minus 3t will be 4t minus 3. That's my velocity function. Now, when is the object stationary? To find that out, for it to be stationary, that means the velocity function will have to be equal to 0. Or f prime of t will have to be equal to 0. And my velocity function there is 4t minus 3 equal to 0. Now if I add 3 to both sides, I'll get 4t is equal to 3. Divide both sides by 4, you'll get t is equal to 3/4. Okay? So it's stationary at time t equaling to 3/4 seconds. Now, let's find out where the intervals where it's moving to the right. Where the object is moving to the right. We got 4t minus 3, so what I'm going to do here is put I'm clearing these equations out. I'm going to put 4t minus 3 in the calculators for x minus 3. And we're going from 0 to 4, so let's do this. X min will be 0 and x max will be 4. The x scale will be 1. X min 0 to 10, and then graph. Now, better yet, let me include negative values for the y. I'm going to say negative 4 to 10. Okay, there we go. Now, in this case here, if it's moving to the right, it's got to be above the x-axis. So here's 3/4 right here. Anything bigger than 3/4 has got to be above the x-axis, so it's moving to the right on this interval from 3/4 up to 4. Because our restrictions from 0 to 4. And we cannot include 3/4. That's why you see the parentheses there, because that's where the object is stationary. And then the interval where it's moving, where the object is moving to the left. Well, looking at this line is 4t minus 3 is below the x-axis here, less than 3/4. You can see it's below that x-axis. So it's moving to the left from 0 to 3/4, and we don't include 3/4 again. And that's a bracket where that 0 is. So it's moving to the left from 0 to 3/4, moving to the right from 3/4 up to 4. That's part A. Part B, they want the acceleration of the velocity and acceleration of the object when t is equal to 1. So here at t equaling to 1, let's first find the velocity. Well, our velocity function was 4t minus 3. So at t is equal to 1, v of 1 would be 4 times 1 minus 3. 4 times 1 would be 4. 4 minus 3 will be 1. And this will be in feet per second. Okay? Since our units are in feet, and the time is in seconds. So at time equaling to 1, the velocity of that object will be 1 foot per second. And then for the acceleration, a of t is equal to the derivative of our velocity function. Well, if our velocity function is 4t minus 3, then its derivative will have to be 4. Derivative of 4t is 4. The derivative of minus 3 is 0. So the acceleration a of t will have to be equal to 4. Now at t equal 1, a of 1, that's simple. It's just going to be 4. Okay, so that's part B. Now part C, they want you to determine the acceleration of the object when its velocity is 0. So what they're saying is this. They want v of t to be equal to 0. And v of t was 4t minus 3, equaling to 0. Well, we've already solved this equation for t, so it should be 3/4. So we're going to find the acceleration when the time is equal to 3/4. And of course, our a of t from part B came out to be 4, so that means a of 3/4 will also be equal to 4, since it's a constant. Okay, so at 3/4 of a second, our acceleration would be 4, and this will be in 4 feet per square second. And the same thing up here, feet per square second. Okay, so that's problem number 9. Okay, problem number 10 is using the chain rule to find the derivative of the function y is equal to sine of 7x to the 4th plus 6x plus 4. So we have to use a chain rule on this one. So here we got y equal to the sine of 7x to the 4th plus 6x plus 4.